Assalamu alaikum, dear students. I am Rashid Kenny, and today I am delivering my ninth lecture on the topic triangles, quadrilaterals, and polygon. This is exercise 11C. In previous lecture, that is in lecture number 8, I have delivered and solved problems from question number 1 to question number 8 of this exercise. This is O-level maths, D1 mathematics, and today I am going to solve question number 9 and onward. And the question number 9 is this one. Three of exterior angles of an n-sided polygon are 15 degree, 25 degree, and 70 degree, and the remaining exterior angles are 50 degree each. Find the value of n. So this is an n-sided polygon having n angles, total of n angles. Okay, three of which are given, that is, one is 15 degrees, 25 degrees, and 70 degrees. And if we subtract these three angles from total number of angles, which is n, the remaining angles will be n minus 3, and each of those angles is equals to 50 degrees. So we add these angles and put them equals to the sum of exterior angle, and sum of exterior angle is always equals to 360 degree. So let us solve this question. Sum of exterior angles of polygons is 360 degree, and three of them are three of exterior angles are given in the question. These angles are 15 degree, 25 degree, and 70 degrees. These are three angles, and remaining number of angles remaining number of angles are of 50 degree each. Remaining numbers of angles are of 50 degree each, and the remaining numbers are n minus 3. Now we add these angles. So first of all, n minus 3 angles, each of magnitude 50 degrees. We multiply the number n minus 3 with 50, which represents the number of angles except these three angles, plus we add these three angles which are of different sizes, and they are given 15 degree plus 25 degree and plus 70 degree. We put this sum equals to 360 degree. Solving this equation, we get the number of sides in this polygon, that is the value of n. So the 50n as it is minus 150, this sum 15 plus 25 plus 70 is 110 is equals to 360. Subtracting 110 from 150, we get 50n minus 40 equals to 360. We add 40 in the right side, so 50n equals to 360 plus 40. 360 plus 40 is 400, so 50n is equals to 400. Dividing 50 in the right side, we get the value of n, that is 400 divided by 50, and the value of n is equals to 8. This is the number of sides of the given polygon having three of the angles equals to 15 degrees, 25 degrees, and 70 degrees, and the remaining n minus 3 angles each of size equals to 50 degrees. Solving this, we get the number of sides of this polygon. This was the question number 9, and now we will solve the question number 10. This is the question number 10. There are three of exterior angles of an n-sided polygon are 50 degree each. There is an n-sided polygon in which three of the angles are of 50 degree each. Two of its interior angles are 127 and 135. To solve this question, we need to find all the exterior angles. So these two interior angles, that is 127 and 135, are given, but we need to find the exterior angle that are related to these interiors. To subtract the interior from 180 degree, we get the exterior angle with 127 and 135, and two exterior angles are will be there, and the remaining interior angles are 173 degrees each, and the remaining angles will be equals to 173 degrees. We have to find the exterior angle with whose interior is given, that is 173. To subtract from 180 degree, we get the exterior with the 173 degrees. Find the values of n. We have to find the value of n, so let us solve this question. So three exterior angles of n-sided polygon. Three exterior angles are equals to 50 degree each. These three exterior angles are of size 50 degree each. Now we find the exterior with whose interior is given, that is 127 degrees. Exterior angle with exterior angle with 127 degrees is equals to 180 minus 127. Subtracting 127 from 180, we get the exterior angle, that is 53 degrees. Exterior angle with the next interior, that is 135 degrees. With 135 degrees is equals to 180 minus 135 equals to 45 degrees. So these are five exterior angles. Three of them are 50 degrees. One exterior angle is 53 degrees, and one exterior angle is 45 degrees. These are three exterior angles. Three exterior angles are of 50 degree. One exterior is 53 degree, and the last one exterior is 45 degrees. So we have a total five of these exterior angles, and the remaining interiors interior angles are of 173 degrees each. So except these five angles, the remaining interior angle are of 173 degrees. So the exterior with 173 degree is equals to 180 minus 173 is equals to 77 degree each. So all the remaining angles of n-sided polygons are of 7 degree each. Now we add these angles. Three of the exterior angles are of 50 degree each. So we multiply 3 by 50 plus one exterior is of 53 degree. We add 53 degree over here, plus another one exterior angle is of 45 degree. So we add 45 over here, and remaining these angles are five angles. So and the number of exterior angle total is n. We subtract 5 from n to get the remaining number of angles, that is n minus 5, and these all n minus 5 angles are of 7 degree each. So we multiply n minus 5 with 7 and we put this sum equals to 360 degree, because the sum of exterior angles of any polygon is equals to 360 degree. Now we solve this equation to find the value of n, that is the number of sides. 50 times 3 is 150 plus 53 plus 45 plus n minus 5 into 7 degrees equals to 360 degrees. We add first three of the numbers, that is 150, 53 and 45. Adding them we get 248. 248 degrees plus n minus 5 into 7 equals to 360 degree. We subtract 248 in the right side and we left with n minus 5 times 7 equals to 360 minus 248. Subtracting 248 from 360 we get n minus 5 times 7. 360 minus 248 is equals to 112. As 7 is multiplying in the left side, we divide the right side by 7. So n minus 5 is equals to 112 over 7. Dividing 112 by 7 we get 16. N minus 5 equals to 16. We add 5 in the right side, so the value of n is 16 plus 5 and the value of n now is 21. So this polygon has 21 sides. So this was the question number 10. Now we will solve the question number 11. Question number 11 is A, B, C, D, E, F, G is a regular heptagon. Heptagon means a seven-sided polygon. Regular means all the sides of this polygon are equal in length. So this is the regular heptagon. If AB and DC, these two sides AB and DC are produced to meet at H, find the value of BHC. We have to find this angle producing the line AB and DC, where these two lines intersects each other. There will be the point H and we need to find the angle BHC. So let us solve this question. So this is the regular heptagon, a seven-sided polygon. We need to produce the side AB and DC. So let us produce AB. This is AB which is produced now, and we also produce DC. DC is produced in this way. So this becomes the point of intersection, that is H. We need to find this angle at point H. So as we know, the sum of exterior angles of any polygon is 360 degree, as the sum of exterior angles of a polygon is equals to 360 degree. We need to find the one exterior angle, and one exterior angle is equals to 360 over 7, because this is the regular heptagon, a polygon with 7 sides. So we divide the sum of exterior angles by 7 to get one exterior angle. So 360 divided by 7 is 51.43. 51.43. 51.43. So this is the exterior angle, each exterior angle of this heptagon. So this angle at point B is the exterior, and angle at point C is this. Both these angles are equals to 51.43. So this angle is equals to 51.43, and this angle is also equals to 51.43. Now we have to find the angle at point H, that is the angle BHC. So we will consider this triangle BHC. In triangle BHC, angle BHC plus 51.43 plus 51.43 is equals to 180 degree, because sum of interior angles of triangle is always equals to 180 degree. We subtract these two angles from 180. BHC is equals to 180 minus 51.43 minus 51.43. Subtracting these two angles from 180, 180 minus 51.43 minus 51.43 is equals to 77.14. 77.14. So angle BHC is equals to 77.14. 14 degrees. This is the angle at point H, that is 77.14 degrees. So hence the question number 11 is solved. Now we will solve the question number 12. The points A, B, C and D are consecutive vertices of a regular polygon with 20 sides. This is the question number 12. The polygon has 20 sides and A, B, C, D are its consecutive vertices. Find the angle ABC and ABD. We have to find these two angles. So let us solve this question. So this is a 20-sided polygon whose some vertices are given, where A, B, C and D are the consecutive vertices of this polygon. We need to find the first angle, that is in first part, that is the angle ABC, and you can see this is the angle ABC, which is the interior angle. To find the interior angle, we first find its exterior angle, and subtracting exterior from 180, we get this interior, that is angle ABC. So, as we know, the sum of exterior angles is equals to 360. The polygon has 20 sides, and the number of sides is equals to 20. So each exterior angle, we divide this 360 by 20 to get the each exterior angle, and the each exterior angle will be equals to 18 degree. Dividing 360 by the number of sides, or sum of exterior angles by the total number of sides, we get each exterior angle. So if we produce CB in this way, this becomes then exterior angle, which is equals to 18 degree, and you can see the line produced from B toward E is a straight line. CBE now is a straight line, and the sum of these two angles, that is ABC and ABE, now is 180 degree. That the sum of angle ABC plus 18 degree is equals to 180 degree, because angles in a straight line. The reason for that, the angles in a straight line. So ABC is equals to 180 minus 18. Subtracting 18 from 180, we get the angle ABC that is 162 degrees. So this becomes the angle ABC. To find ABC, which was the interior angle, we need to find the exterior one. This was the interior angle ABC. To find that, we find the exterior angle, which is 18 degrees, and adding A, B, C with 18 degrees and putting them equals to 180 degree, because 18 degree and this internal angle lies in a straight line. We get the interior angle ABC. So this is the method to find this angle. Now we need to find the angle ABD. And to find the angle ABD, we have to find this angle ABD. We need to find these two angles, CBD and CDB. We first find these two angles. Both of these angles are equal in size, because all the sides of a regular polygon are equal. So angle opposite to the equal sides are equal. So these two angles are equal in size, and we know now the sum of each interior angle of a regular polygon is equals to 162 degrees. So angle uh, BCD is also equals to 162 degrees. We put the sum of these three angles equals to 180 degree to find the value of x. So in triangles, we are solving part 2. In triangle BCD, BCD, the sum of interior angle is x degree plus 162 degree is equals to 180 degree. Subtracting 2x degree equals to 180 minus 162, we get 2x degree is equals to 18 degree. Oh, sorry, 18 degree. 18 degree, dividing 18 degree by 2, we get the value of x, that is 9 degree. Now we need to find the angle which is marked green, ABD. As we know that angle ABC, angle ABC is equals to 162 degree, which is the interior angle, which we have find in part 1. We subtract the value of x from 162 degree to obtain this angle. So the angle ABD is equals to 162 degree minus x degree. So this equals to 162 minus 9 degree. We get the angle which is equals to 153 degrees. So this becomes the answer of this question. I hope you understand. This was the question number 12, and now we will solve the question number 13. So this is the question number 13. In the figure, A, B, C, D, E is a regular pentagon, and A, B, P, Q, R, S is a regular hexagon. Both the polygons are regular, that all the sides are equal in length. X is the center of the hexagon. This X is the center of hexagon. And these diagram is here. X is the center of hexagon, and this is a conjective pentagon and hexagon also. We have to find all these angles ABP, PQX, AXB, ABC, ACD, and ASE. These angles are to be found. So let us solve this question number 13. So this is the question number 13. We first of all we have to find this angle, that is ABP. First part, ABP. You know that ABP is the internal angle of hexagon, and this is the regular hexagon. We know that sum of interior angles of any polygon, exterior angles of any polygon is equals to 360 degree. So sum of exterior angles is equals to 360. Number of sides in hexagon are 6. So we divide 360 to get each angle each internal angle of hexagon, each external angle of hexagon. So each external angle is equals to 360 divided by 6, because 6 is the number of sides of hexagon. Dividing it by 6, we get 6. 360 divided by 6, 60. So each exterior angle of hexagon is equals to 60 degree. Now each interior angle of hexagon is equals to 180 minus 60. We subtract the exterior angle from 180 to get the interior angle, and this becomes 120 degree. And as ABP is interior angle, so ABP is equals to 120 degrees. Not only ABP, but each interior angle is equals to 180 degree of this hexagon. Now let us solve the part 2. And what is required in part 2? Part 2 is PQX, angle PQX. PQX. This is the angle which is required now. PQX. So actually we know that the angle PQR, which is the interior angle, that is this angle, is equals to PQR is equals to 120 degree. So the PQX angle, which is half of it, is equals to 120 divided by 2, because the line QR bisects this angle. As this is regular hexagon and the line QR bisects the angle PQR, so the angle PQX is equals to half of angle PQR. So dividing it by 2, we get 60 degrees. Angle PQX is now 60 degrees. Hence, part 2 is solved. Now in third part is AXB. Third part is AXB. This is the angle in third part which is required, AXB. We have to find this angle. We can consider ABC as an equilateral triangle, and each interior angle in an equilateral triangle equals to 60 degree, but we solve it in another way. As X is the midpoint of this hexagon, and around X we have 6 sides, so 6 angles can be made, and all the angles in this hexagon are equals to 360 degrees. So sum of angle around X, part third. Angles around X is equals to 360 degrees. 360 degrees. And the sides around X is equals to 6. So AXB angle, AXB is equals to 360 divided by 6 is equals to 60 degree. So this is the angle AXB, because angle at a point, sum of angles at a point is equals to 360 degree, and we have one side which made angle AXB. So we divide it by 6 to get the angle AXB. So this is AXB angle. Now we will solve the part 4 of this question. Let us raise that. And part 4 is ABC. Part 4 is the angle ABC. So this is the angle which is required now, angle ABC, as ABCDE is a pentagon. So part 4, sum of interior angles in pentagon is equals to n minus 2 times 180. We put the value of n equals to 5 to get the sum of interior angles of pentagon because pentagon has 5 sides. So 5 minus 2 times 180, it means 3 times 180, and multiplying 180 by 3 we get 540. We get 540. And the pentagon has 5 sides. So each interior angle of pentagon is equals to 540. We divide the sum of interior angles of pentagon by 5 because pentagon has 5 sides. Dividing it by 5 we get the angle that is equals to 108 degrees. 108 degrees. So the angle which was required in part 4 was ABC. ABC, this angle now is equals to 108 degrees. So this was the part 4 of question number 13. Now let us solve the part 5, and the part 5 is ACB. So this is the point A, we join it with C, ACD. So this is the angle which is required, ACD. To find this angle, we need to have this angle. Let this angle is equals to x degree, and this angle is also equals to x degree because pentagon, this is the pentagon with regular pentagon and all the sides are equal. The angle opposite to the equivalent sides are equal. So these two angles are equals to x degree, and we know this angle ABC, this angle is equals to 108 degrees. We use the triangle ABC to get the value of x first. So the part 5 is in triangle ABC. We know three angles in triangle ABC, that is x degree, and 100 degree marked 108 degree marked green. So in triangle ABC we have three angles, that is x degree plus x degree plus 108 degrees equals to 180 degree because sum of interior angles of a triangle is equals to 180 degree. Adding them 2x degree and subtracting 108 from 180, we get the value of 2x degree which is equals to 72 degrees. Dividing it by 2 we get the value of x degree, that is 72 over 2, which is equals to 36 degrees. So the value of x now is 36 degrees. So this angle BCA is equals to 36 degrees. So this angle is 36 degrees. As we know that the interior angle of this pentagon is equals to 108 degree. To find the angle ACD, we subtract 36 degree from 108 degree. So angle ACD Angle ACD is equals to 108 minus 36. Subtracting 36 from 108, we get the angle which is equals to 72 degrees, which is equals to 72 degrees. So this angle is equals to 72 degrees. Angle ACD is equals to 72 degrees. Hence, the part 5 is solved. Now we will solve the part 6. Deleting all these values, I am deleting these extra writing because you should not feel any difficulty to understand the part 6, and the part 6 is required angle ASE. Angle ASE. So let us join the point S and E with the help of a straight line. So this is the triangle ASE, and this angle ASE is required. We have to find this angle. To find this angle, we need to know that AS and AE are two equal sides, and angle opposite to them are also equal. Let us consider that this angle is equals to x degree, as this side and this side is equal. So this angle is also equals to x degree, angle opposite to the equivalent side. We need to find the angle at point A. As we know that in hexagon all the interior angles are equals to 120 degree, and in pentagon all the angles interior angle are equals to 108 degrees. So sum of these angles is equals to 60 degree at point A. Okay. So we put the sum of these angles at point A to find the angle at point angle SAE equals to 360 degree. Part 6, angle ASE is required, and the angles at point A, one is 120 degree, other one is 108 degree, and the angle SAE. SAE. These sum of these angles at point A is equals to 360 degree, because these are the angle at a point, so their sum is equals to 360 degree. To find angle SAE, we subtract these two angles from 360 degree. 360 degree minus 120 minus 108. Subtracting these two angles from 360 degree, we get the angle SAE, which is equals to 132 degrees. 132 degrees. So the angle at point A in triangle SAE is 132 degrees. Now we consider the triangle SAE where two angles are of x degrees and one angle is of 132 degrees. We put this sum equals to 180 degree. So in triangle SAE, we have two angles equals to x degree plus x degree, and the angle at point A is 132 degrees. We put this sum equals to 180 degree. Subtracting 132 from 180, we get 2x degree equals to 180 minus 132. So 2x degree equals to 180 minus 132 is 48 degrees. 48 degrees. Dividing it by 2, x degree is equals to 48 over 2, which is equals to 24 degrees. Its mean angle ASE is equals to 24 degrees. Hence the question number 13 with all the parts is solved. I hope you understand that question. Now we will solve the question number 14 is, in the figure ABCDE is a part of n-sided regular polygon. The ratio of interior angles to an exterior angle of this polygon is 5:1. So this is the part of n-sided polygon. Uh, from n-sided polygon we have A, B, B, C, C, D and D, E. We have four of these sides of n-sided polygon. The first thing is we have to find the value of n and these two angles. So let us solve this question, and the ratio of interior to exterior interior angle to exterior angle is this one, 5:1. So let us solve this question. As we know that sum of interior angles sum of interior angles is equals to n minus 2 times 180, and the sum of exterior angles is equals to 360 degree. This is the sum of exterior angle and this is the sum of interior angle, and the given ratio is interior angles to exterior angle is 5:1. So we put this according to given condition. According to given condition, we put this ratio, that is the sum of interior angles n minus 2 times 180 ratio sum of exterior angle, that is 360, is equals to 5:1. As by given condition it is given that the sum of interior angles to the ratio of interior angles to the exterior angle, this one, the ratio of an interior angle to an exterior angle is of the polygon is 5:1. So we do not know the exactly the interior angle or exterior angle, so we put the sum of interior angles ratio, the sum of exterior angle, which is 360, equals to 5:1. Now we solve this ratio and proportion, that n minus 2 times 180, the ratio is converted into fraction divided by 360 equals to 5 divided by 1. We multiply 360 in the right side and we get n minus 2 times 180 equals to 5 times 360. So in the left side, 180 is multiplying with n minus 2. We divide the right side by 180. So the value of n minus 2 will be 5 times 360 over 180. If we multiply 180 by 2, we get 360. So the answer will be 5 twos are 10. So the value of n minus 2 is equals to 10, and hence we get the value of n, which is equals to 10 plus 2, and it is equals to 12. So this is the value of n. Now we will find the angle ACD. Angle ACD. So this was the angle ACD, which is the interior angle, and we know that the sum of interior angles of n-sided polygon is sum of interior angles is equals to n minus 2 times 180, and the value of n, as we have solved in part 1, is 12. So we put the value of n equals to 12 here. So 12 minus 2 times 180. This becomes 10 times 180. As the number of sides in this polygon is equals to 12, so we divide this sum of interior angles by 12 to get the each interior angle. So each interior angle now is equals to 10 times 180 divided by 12. We can divide 180 by 12. 180 divided by 12 is equals to 15. So 10, 12, 15s are 180. So 10 multiplied by 15 and 15 tens are 150. It means that each interior angle is equals to 150, and the angle which is required in the part 1 ACD need to be find, but we have find the angle BCD. The angle BCD is now equals to 150 degree. Angle BCD is equals to 150 degree. To find the angle ACD, that is, we need to find this angle ACD. We have to find this angle. To find this angle, we need to find this angle. If the line AB is equals to the line BC, then the angle at point C is equals to x degree, and angle at point A is also equals to x degree, because the angle opposite to the equivalent side are equal, as each interior angle of this polygon is equals to 150. So angle ABC is also equals to 150 degree. So we consider the triangle ABC to find the value of x, which is the angle BCA, and we subtract this angle from angle BCD to get the angle ACD. So let us consider the triangle ABC. In triangle ABC, we have two angles equals to x degree, that is x degree plus x degree, and the third angle is of 150 degree. We put this sum equals to 180 degree. So 2x degree equals to 180 minus 150. 2x degree is equals to 30 degree. Dividing it by 2, we get the value of x degree, which is equals to 15 degrees. It means that angle BCA is equals to angle BCA is equals to sorry angle BCA is equals to 15 degree. Now to get the angle ACD, we subtract angle ACD. We subtract angle BCA from the angle BCD. BCD minus BCA. Angle BCD is the interior angle of this polygon, and all the interior angle of this polygon are equals to 150 degree. We subtract the angle BCA, which is equals to now 15 degrees. So subtracting 15 degrees from 150, we get the angle which is equals to 135 degrees, which is the angle ACD, and which was required in the part second of this question. So hence we have find the angle ACD. Now we will find the angle that is required in the third part here, angle ADE. Angle ADE. So this is the angle which is now required, angle ADE. To find the angle ADE, we need to find the angle ADC first. Angle ADC first. This angle. Let this angle is equals to y degree, and we know the angle ACD, which is equals to now 135 degree. This angle is now equals to 135 degrees. As you can see, the line CD is equals to the line AB. So complete angle at point A is also equals to y degree, because AB and CD are equal lines, because this is a regular polygon, and these two angles are of y degree, and we know that the angle at point B is equals to 150 degree. Angle at point C is also equals to 150 degree. Complete angle 135 plus 15 is 150 degree. So we know the four angles in this quadrilateral ABCD, that the two angles are equals to 150 degree, and the remaining two are equals to y degree. We put the sum of these four angles equals to 360 degree, and because we know that the sum of angles in a quadrilateral are equals to 360 degree. So let us solve this part. The third part is in quadrilateral. In quadrilateral A, B, C, D, we know the interior angles, that is the angle at point B is 150 degree. At the same time, angle at point C is 150 degree. Angle at point A is y degree and angle at point D is also y degree. And we put this sum equals to 360 degree. This becomes 2y degree equals to 360 minus 150 minus 150. 2y degree equals to 360 minus these two angles is equals to 60 degree. Dividing it by 2, we get the value of y degree, which is equals to 30 degree. Hence we get the value of y degree now, which is equals to 30 degree. Now the complete angle, this CDE is equals to 150 degree, because the interior angles are equals to 150 degree. CDE is equals to 150 degree. We subtract y degree from 150 degree to get the angle ADE. So ADE is equals to 150 minus 30, which is equals to 120 degrees. So the angle ADE is 120 degrees. Hence this was the question number 14, and now we will solve the question number 15. The question number 15 is, in the figure A, B, C, D, E, F is a part of n-sided regular polygon. Each exterior angle of this polygon is 36 degrees. So A, B, C, D, E, F is the part of a regular polygon, and in which each exterior angle is of 36 degrees. We know that the sum of exterior angles of a polygon is equals to 36 degrees. To get each exterior angle, we divide 360 by 36 to get the each exterior angle, and we subtract that exterior angle from 180 to get the get interior angle. But in this question, we have to find the value of n and these two angles BDE and CXD. So let us solve this question. So this is the question number 15. A, B, C, D, E, F is the part of a regular polygon, and first we have to find the value of n, as we know that sum of exterior angles is always equals to 360 degree. Each exterior angle, he has told us each exterior angle now is equals to 36 degrees, as there each exterior angle of this polygon is 36 degrees. So we know the each exterior angle also. We divide the sum of exterior angle by each exterior angle to get the number of sides. So the value of n, that is the number of sides equals to n is equals to 360 divided by 36. Dividing 360 by 36, 360 divided by 36 is equals to 10. So this polygon has 10 number of sides. So the value of n is 10. Now we will find the angle in second part, angle BDE. We have to find the angle BDE. We are going to find this angle BDE, and now we know each each exterior angle, and we also know the interior angle, that is the each interior angle is equals to 180 minus 36, and each interior angle is 180 minus 36 is equals to 144 degrees, and now each interior angle is equals to 144 degrees. So the angle CDE complete is 144 degrees. we need to find the angle, that is this one. So we subtract this angle from 144 degrees to get the angle BDE. So for that we know that the side CD is equals to the side BC. It means that if this angle is equals to x degree, then this angle at point B is also equals to x degree. I have draw this triangle BCD over here. If this angle at point D is x degree, then this angle at point B is also x degree, because the line BC is equals to the line CD, and the angle at point C is now equals to 144 degrees, because it is the interior angle. So we consider the triangle. In triangle BCD, the sum of interior angle, one is x degree, other one is also x degree, and the third one is 144 degree. We put this sum equals to 180 degree. So it becomes 2x degree equals to 180 minus 144. Subtracting 144 from 180, we get the angle which is equals to 36 degrees. 36 degrees. Dividing it by 2, we get the value of x, that is 18 degrees. So the value of x now is equals to 18 degrees. So this x value is equals to 18 degrees. To get the angle BDE, BDE, BDE will be equals to the angle CDE minus CDB, minus CDB. So CDE is the interior angle which is equals to 144. We subtract 18 from 144 to get the angle BDE, and 144 minus 18. 144 minus 18 is equals to 126 degrees. So the angle BDE is equals to 126 degrees. So this is the part 2 of this question, and now we will solve the part 3rd. The third part is CXD. Let us draw the triangle CXD over here. Let this is the triangle CXD. This is the point X, this is the point C, and this is the point D. We have to find this angle which is CXD, and you know what? If these two lines CX and DX are equal in length, CX and DX are equal in length. So if these two lines are equal in length, then we know the angle at point D, which is equals to 18 degree. That is the angle BDC. The angle BDC is equals to x degree, which is the value of x degree is 18 degree. Then the angle at point C is also 18 degree in triangle CXD. So we consider the triangle CXD to get the angle CXD. In triangle CXD, we know the two angles, that is one is 18 degree, other one is also 18 degree, and the third one is angle CXD. Here sum is equals to 180 degree, because these are the interior angles of the triangle. So the angle CXD is equals to 180 minus 18 minus 18, subtracting 36 from 180, we get the angle which is equals to 144. So CXD is equals to 144 degrees. And so this was the question number 15. I hope you understand. And with question number 15, I just end my lecture for today. In my next lecture, I will solve question number 16 to question number 19 of this exercise. So till then, take care of yourself, and do not forget to subscribe my channel. Thank you very much.